introduced as David Skip from Ford Motor Company, but my speaking role today is primarily on behalf of the UK Automotive Council. And what I'd like to do is present the roadmap that Alan introduced a few moments ago, Roadmap for Connected and Autonomous Vehicles. And that was launched last month at the LCV17 event. Now, one of the questions I got at that event, I hope it was tongue-in-cheek, was if autonomous vehicles are so intelligent, why do they need a roadmap? So that's going to be my starting point for today, but I'll also take you through the roadmap and where it might lead us and start the conversation on where should we focus next. So why does an autonomous vehicle need a roadmap? Well, the answer is it doesn't, but perhaps we do. The point of the roadmap is to start the dialogue around where do we want autonomous and connected vehicles to play a part in our lives and in our future world. And that we is not just us, the industry with our government partners that, again, Alan introduced. It's us and our customers, the travelling population of Britain, Europe and the world, and also the city partners and the transit authorities where our connected and autonomous vehicles will integrate and play a part in making their lives better. So the roadmap is about where we would like to go. So taking those three perspectives in turn by way of introduction, the Automotive Council is a collaboration between industry and government, and its purpose really is to strengthen and grow the industry. And it does that through creating insight, through establishing strategies and really driving the right initiatives forward to gain an impact. And it does that across three spaces: the business space, the supply chain and the technology world. And the point of our roadmap is to address the 5 priorities on the left-hand side. You'll see CAV, environment and capability, is one of those, and put the stretch into the engineering task ahead to drive the academic agenda, but also to drive the application opportunities so that the demonstrators in the public domain that create awareness and drive demand are clear and apparent to the public and the media. So the roadmap's role is to highlight the technology potential. From the traveller perspective, they're our customer base, and if we're going to be successful here, we need them to want to buy our products. We need to give them what they want at a price that they can afford. Now, to understand that, we reflected back on the 2015 Traveller Needs Study, which pulled in insight from over 10,000 travellers across the UK. It looked at their daily journey travel diaries, it looked at their pain points, and it looked at their willingness to pay for improved services. And for example, one of the major pain points was the everyday parking challenge that many of us face. And the study identified that for every parking event, for every traveller on every day throughout the year, the willingness to pay was 42p, which is a single amount. Doesn't sound like a huge amount, but aggregate that up and it's millions and millions of potential revenue for a connected and autonomous type of service. So that gives us some insight into the traveller demand and the pull. But what we felt we had to do next was to translate all of that insight into a mobility set of roadmaps, and this is the work that Alan referred to, and a big thank you to the AESIN team members that supported that. And that broader understanding that looked at aspects like town planning, like behaviour change, as well as the role of technology, allowed us to distill out where we felt connected and autonomous vehicles could really influence that mobility world we read about in the magazines. So the point being, we've got to make sure this roadmap is relevant to the travellers that are going to use the services. And lastly, the cities, the transit authorities are also a customer. And enough has been said in other conferences about mega cities and mega trends, so I'm not going to repeat that story. But the point being that those cities and transit authorities give us permission, license to operate our vehicles and services. And they have a duty of care for their citizens. So we need to respect their needs and make sure that the social benefits of our new products and services outweigh the social costs. So those three perspectives really frame the roadmap, from the immediate challenges of setting an industrial strategy, of addressing CO2 and air quality and solving that parking challenge on the near-term side, to achieving GDP growth and productivity impact, mobility equality, and end-to-end mobility services on the right-hand side. Now, it feels like the SAE autonomy levels are new language. You see it in the press, you hear about it in our conferences, and you actually start to hear it in the pubs and restaurants now. So that SAE layer is the first part of our roadmap, and what we're showing there is the first introduction of SAE 4 and 5 vehicles and products, services in around the 2020 timeframe, where many public announcements have been made, but likely focusing on high utilization commercial opportunities where payback of probably expensive early services can be more likely achieved, and also focusing in known stable environments, probably at lower speed. But that coverage of geography and environment expanding as time moves forward. And we're showing that in parallel with the SA2 driver assist features, which are already in the marketplace today and continue to grow both in their adoption and in their capability. And that's a trend we see happening for this foreseeable future. There will be, we think, geographies where SAE 2 and 3 continue to be relevant. The scope with which SAE 3 prevails is not really clear at the moment, likely in some of them, again, of the commercial applications such as the platooning motorways and highways. The next layer in the roadmap is the attribute layer, and this is the layer that explains the benefits, the why are we doing this, and safety feels like that's the dominant factor here. We've spent a long time developing and deploying driver assistance, and that is having a real impact in the marketplace now, both in terms of customer acceptance and impact on rear-end accidents and insurance claims. So that's a trend that's going to continue, and against that backdrop, it feels like the first autonomous vehicle applications will need to show a significant improvement, something like an order of magnitude improvement in safety, to keep that good reputation that we hope that they will gain. And over time, we expect attitudes to normalize to that improvement in behavior, so that we really, in the future, need to be targeting something like a 2-order improvement in safety as the technology matures, to keep that license to operate. Beyond safety, we think it's about convenience, productivity, and efficiency, whether that's availability of real-time information to assist journey planning and to sponsor and encourage behavior change, whether that's optimization of the network, using predictive information to solve challenges before they actually occur, whether that's the deployment of autonomous services that allow us to sit back and relax and become more productive and more entertained as we travel. So the destination is compelling. It's an automated, network-optimized future, productive travel, and it's much, much safer. But to do that, there are some technology challenges. And these challenges are really about how we transform information, data, throughout that mobility autonomy chain of events, from the sensor, which is about translating the physical world into the virtual world, a transformation. And we'll do that with increasing use of sensor fusion, new sensors, edge processing, shared sensor data across networks, all of that about bringing increased sensing capability at reduced cost. For processing, we're going to start the introduction of machine learning on board. We're going to start joining up networks of pods and networks of traffic lights with centralized machine learning to try and optimize at that slightly higher system level. And beyond that, we're going to start joining these systems together and think about optimizing at the system of systems level. Communications, we can do a lot with 4G, but there's a latent next-gen set of technology out there that gives low latency communication that will allow us a greater degree of safety functionality. Not clear when that will happen, but that's an essential next step in moving towards a swarm-type network of information sharing and processing. And lastly, the machine world has got to communicate back with the real world. It's got to communicate to pedestrians and passers-by. It's got to communicate to travellers, to operators, to service agents. So understanding and combining voice with gesture, with eye movement, that sensor fusion, and integrating that in the way we go about our daily lives in a seamless way is an essential part of this technology layer. And as I said, I think the most difficult part of that technology is actually around the business and the specification alignment around that next-gen communications transition. Now, the last layer are the enablers. These are the things that help us move and govern the way that we move from a human-driven environment to a machine-driven environment. And there's a lot that we have to prove to keep that trust. We have to prove safety, robustness through time. We need to make sure that we can account for the decisions the machines will take and that those decision processes are auditable and transparent, and that the system is continuously managing safety and optimizing for safety and prove that everything is secure and compliant. And simulation is going to play a huge role in doing that, really with soup to nuts, end-to-end simulation of the sensor input, the sensor output, the processing of that information to detect objects, to anticipate what's going to happen next, to make a decision, to actuate that upon that decision, and to translate that into signals out into the real world, to simulate the impact that will then have, and what will the real world then do next, and then to close that loop. So that process of simulating the validation and certification process is a huge challenge, and we've shown that extending out over the next decade and more. So wrapping all that up, we think we've captured those three critical aspects: the technology challenges that will stretch and drive the academic agenda, the attributes that give the traveller something that they will want to pay for, and the enablers that help the transit authorities and the city layer transition and govern our pathway to the future. And we've done all of that on one A4 page, which has been a tremendous challenge, and thank you again to the AESIN group for assisting in doing that. Now that can be a little bit daunting, and the next question is, so what do we do? So I'd like to change my speaking perspective a little bit and show you some thoughts from the forward side of how we dealt with the last few years and months as we've struggled with these challenges. I think the first point is, when you're faced with such a broad opportunity area, it's hard to see the wood for the trees when you've only got your own perspective. So what we've found really helpful is to go out and get some more. And we've arranged a number of these innovation challenges where we've reached out way beyond automotive into other sectors and customers and lifestyles, and just trying to capture the ideas and the opportunities. Nothing more, just to capture them, soak on them, process them, and start to think about how would that impact us? What does this future world start to look like? And you don't have to go to the other side of the world to do this. There are travellers with pain points in every village, town and city in the UK. And as I was reminded again this morning, if there's one thing the UK is world class at, it's congestion. So we can find a lot locally. When you've started to find those ideas and opportunities, it's probably still too early to launch a new venture or a new technology. So the way that we've handled this is to experiment. And these are proper, thought-through, multi-phase designs of experiments that will trial a new technology or a service design over a period of time, months typically. And when we felt we've proven our understanding, confirmed the cause and effects we've been looking for, the noise factor inferences, the control factor inferences, we've shut the experiment down. Sometimes we've found some new and novel things we didn't expect, and we might extend the experiment a little bit. But it's a way of really confirming, consolidating what you know about the emerging ecosystem and what you can expect. And then to take those ideas forward, consortiums are a really good way to reach out to skill sets that you don't possess inside your own organisation. Not just to assess technology, where you can build prototype demonstrators as I'm showing on the left, but also experiment with the service, with the technology in a real application world. On the track and on the road, we're demonstrating with the consortium V2V and V2I features in a way that allows us to assess the impact. How many more seconds can we take off that journey of the blue light vehicle to its destination? How valuable is that to the city and the medical authorities? And is that a business driver for introducing V2V and V2I technology? As an example, does green light optimal speed advisory help traffic flow? How much energy does it save? Is that a driver for introducing V2V, V2I technology? So an effective way to develop solutions and assess the technology business case together. So lastly, I'd just like to reflect on the critical challenges, which are the orange bars in the roadmap, and offer what I think is a common theme that runs throughout. From a processing perspective, we're about to see the industrialization of machine learning, not just in autonomous vehicles, but in many aspects of technology. Our world, the autonomous vehicle world, is probably one of the most demanding, chaotic environments you could think to introduce machine learning. And we've got to keep very careful track on how we do that. How do we make sure that the performance of our machine learned algorithms is as intended? How do we confirm traceability and auditability of any incidents that may happen? Huge challenge. Communications I spoke about, we can do a lot with 4G, but there's another transition that allows us an increased level of safety functionality that we've got to work through. The validation and certification challenge, I think we all accept we can't validate all of this in the physical world, and that simulation is going to play a big part. But I would also argue that simulation doesn't allow you to do everything either. Simulation by definition is an approximation, and the world is so chaotic that I bet something happens tomorrow that I forgot to include in my simulation that I did yesterday. So simulation isn't going to be the entire answer. The question really is, how good is good enough? And a similar question revolves around the whole assurance agenda, assurance, the ethics, the legal case, the regulation. And we need a grown-up conversation about how safe is safe enough and what is acceptable in the face of cyber-physical risks. So the common theme through all of this is, although there is huge opportunity for technology and business, there is also a balance that we need to find with our approach to human risk. And getting that right, the right level of risk, not too risk averse, certainly not too risk light, is going to be the differentiator between successful products and successful services as we move forward. And getting that balance right, balancing technology with business, with human factors, great job for engineers. That's what we do. So, to the engineers in the room, enjoy the challenge, and thank you for listening.